Hello, my dear student. Today I am going to discuss or solve Pearson Edexcel International GCSE 9 to 1. Question paper January 2021, Jan 2021. Chemistry Unit 4CH1 Science Double Award 4SDO. Paper 1C. I already have finished question 1, 2, 3 in part 1. Today I am going to discuss question result. Here it is a gas syringe. Initially it has 100 centimeter cube air inside the gas syringe and a conical flux and wet iron fillings. These are the student result. Volume of air in conical flux and connecting tube 265 centimeter cube. Volume of air in conical flux and connecting tube 265 centimeter cube. Volume of air in gas syringe at start 100 centimeter cube. Volume of air in gas syringe at end 25 centimeter cube. Calculate the percentage of oxygen in the sample of air using student's result. First we have to find out the volume. First we have to find out the volume of the oxygen. Volume of the oxygen used. Equal to 100 minus 25, so it is 75 centimeter cube. So percentage of oxygen, equal to 75 divided by total volume 265 plus 100 into 100%. So 75 divided by 365 into 100%. So it is about 20.5%. Now question number, so it is 20.5%. Now question number B1, cars are painted to prevent the iron in car bodies from rusting. Explain how painting prevents the iron in car bodies from rusting. So paint provides a barrier so paint provides a barrier, or paint forms a coating on the iron, number one, and another which prevent oxygen and water getting to or reacting with iron. So car painted to prevent the iron car bodies from rusting. Explain how painting prevents the iron in car bodies from rusting. So paint provides a barrier, or paint forms a coating on the iron which prevent oxygen and water getting or reacting with iron. B2, some car manufacturers use paint containing tiny particle of zinc. Explain how particles of zinc prevent iron in car bodies from rusting even when this paint is scratched. Because zinc is more reactive than iron. So zinc will form oxide or corrode instead of iron, or before iron. Total marks for question 4 equal to 7 marks. Now question number 5. This question is about separation of mixture. The box gives some method used to separate mixture: crystallization, filtration, fractional distillation, simple distillation. Complete the table by giving the correct method from the box for each separation. Each method can be used once, more than once, or not at all. Insoluble solid from a liquid. Insoluble solid from a liquid. Filtration method. So we can use filtration method. Filtration method. Pure water from a solution. Simple distillation. Simple distillation or fractional distillation. Liquid from a mixture of liquid with different boiling point. It is fractional distillation. Soluble solid from a solution. Soluble solid from crystallization method. So insoluble solid from liquid we can separate by filtration. Pure water from a solution, simple distillation method. Liquid from mixture of liquids with different boiling point, fractional distillation method. Soluble solid from a solution, crystallization method. Question number B. A student uses chromatography to analyze the composition of purple ink. The diagram shows the student chromatogram at the end of the experiment. Explain which dyes are contained in the purple ink. A and B. A and B. Because they are same height or move the same distance up the paper. Explain which dye is least soluble in solvent. D. Because the spot is closest to the start line. Or traveled the least distance. Or has the lowest RF value. Question C. A different chromatography experiment is set up. A spot of food coloring is placed on the start line. A food dye in the coloring has an RF value 0.72. The distance between the start line and the solvent form 120 millimeter. Calculate the distance food dye moves from the start line. We know RF value equal to distance the food dye potassium chloride solution with ammonium carbonate, potassium chloride. So no precipitation is formed, no precipitate. Now calcium chloride solution with ammonium carbonate. Ammonium carbonate. Precipitate of calcium carbonate. Calcium carbonate is formed. Question B. A student has 4 unlabeled beakers, each containing a colorless solution of a different salt. The 4 solutions are potassium carbonate, potassium chloride, potassium iodide, sodium chloride. Describe a method to identify each solution. Do not refer to safety in your answer. A student has 4 unlabeled beakers, each containing colorless solution of different salt. The student can do flame test. Sodium chloride produces a yellow flame. Add hydrochloric acid, potassium carbonate, potassium carbonate effervesces or bubbles. Because carbon dioxide gas given off or add dilute nitric acid. Or add silver nitrate solution. Potassium chloride gives a white precipitate. Potassium iodide gives a yellow precipitate. Potassium iodide gives a yellow precipitate. Okay, total for question 6 equal to 9 marks. Total for question 6, 9 marks. This question is about lithium oxide. The oxygen shows the electron configuration of an atom of lithium. The diagram shows the electronic configurations of an atom of lithium and an atom of oxygen. Describe the changes in electronic configuration when lithium and oxygen react to form lithium oxide. Lithium loses one electron or gives one electron to oxygen. Two lithium atom each lost one electron give one electron to oxygen. Oxygen gains two electrons. So lithium ion has has an electron configuration of 2. An oxide ion means oxygen 2 minus is 2,8. Question number B. Lithium oxide reacts with water to form lithium oxide as the only product. A scientist uses this apparatus to measure the temperature changes of the reaction. A beaker, 100-gram water, polystyrene cup, and a thermometer. This is the scientist's method. Pour 100 gram of water into the polystyrene cup. Record the temperature of the water, add the lithium oxide and stir the mixer. Record the maximum temperature reached. The diagram shows the thermometer readings before and after the lithium oxide. So before it is 16, it is 17, it is 18, 19, 20. So before 17, 17.2, 17.2 degrees Celsius, and after adding lithium oxide, temperature becomes 26, 27, 28, 29. So 27.6 degrees Celsius. So before and after reading of the thermometer. Complete the table giving all values to the nearest 0.1 degree Celsius. Temperature in degree Celsius after adding the lithium oxide, 27.7 degrees Celsius. Temperature in degree Celsius before adding the 17.3 degrees Celsius. Temperature in rise, temperature rise. So 27.7 minus 17.3. So answer 10.4 degrees Celsius. Calculate the heat energy change in the reaction. Give your answer to two significant figures. Here see, we know heat energy, calculate the heat energy equal to mass into specific heat capacity into change in temperature. Here mass of water is 100 gram. Mass of water is 100 gram. 100 gram water. And C, specific heat capacity for water, 4.2 joule per gram per degree Celsius. And change in temperature here, 10.4 degrees Celsius. So answer will be 4,368 joule. So we can write 4,400 joule. Remember this formula. Heat change equal to mass into specific heat capacity and change in temperature. In another experiment, the scientist obtains this result. Amount of lithium oxide in mole 0.0580, heat energy change in joule 5210 joule. Calculate the molar enthalpy change delta H in kilojoule per mole. Include in sign in your answer. Amount of lithium oxide in mole. Amount of lithium oxide in mole 0.058. So we know delta H equal to heat energy change divided by amount of lithium oxide in mole. Heat energy change 5210 joule divided by 0.0580 mole. So $89,800 joule per mole. In kilojoule, 89.8 kilojoule per mole. Give a reason why the scientist does the experiment in polystyrene cup. Because polystyrene is a good insulator. Polystyrene is a good insulator. Total for question 7 equal to 13 marks. Now let's start question number 8. This question is about halogen. A. The table gives some information about halogen. Complete the table predicting the physical state of astatine at room temperature and the color of astatine. Fluorine at room temperature it is gas, chlorine also gas, bromine liquid, iodine solid, and astatine mass solid. And color of the astatine dark gray or black. Dark gray or black. Bromine has two isotopes with mass 79 and 81. The relative percentage of each isotope in a sample of bromine are bromine 79 51.51%, bromine 81 49%. Calculate the relative atomic mass of this sample bromine. If your answer 1 decimal place. So RAM relative atomic mass of bromine equal to mass here mass 79 and percentage 51%. plus mass 81 is 49%. 49%. So answer will be $80. So relative atomic mass of bromine is 80. So relative atomic mass of bromine is 80. Give a reason why both isotopes of bromine have the same chemical properties. Chemical properties depends on the electronic configuration. So they have same electron configuration. Electron configuration. They have same electron configuration. Or they have same number of electrons in the outer shell. The outer shell. A student investigates the reactivity of some halogens. She uses this solution of halogen and their halide, bromine, chlorine and iodine, sodium bromide, sodium chloride, sodium iodide. She adds each halogen solution to each halide solution. The table shows her result. Bromine with sodium bromide, no reaction. Bromine with sodium chloride, no reaction. Bromine with sodium iodide, no reaction. Chlorine with sodium bromide, reaction occurs. Chlorine with sodium chloride, no reaction. Chlorine with sodium iodide, reaction occurs. Iodine with sodium bromide, no reaction. Iodine with sodium chloride, no reaction. Iodine with sodium iodide, no reaction. Explain how these results show the order of reactivity of bromine, chlorine and iodine. So the order of reactivity is chlorine most, bromine and iodine least. Chlorine is most reactive because it displaces bromine. It displaces bromine and iodine. Iodine. Bromine is less reactive than chlorine. Since it only displaces or iodine ion loses electrons. Total for question 8 equals to 12 marks. Question number 9. Propane is a hydrocarbon with the formula C3H8. State why propane is a hydrocarbon. Propane contains hydrogen and carbon. So contain propane contains hydrogen and carbon atoms only. Propane in propane hydrogen and carbon are bonded together by covalent bond. Question number B. Name the poisonous gas that forms when propane is burned in a limited supply of air. So carbon monoxide. Carbon monoxide. In sufficient air, it produces a poisonous gas, carbon monoxide. Carbon monoxide. State why this gas is poisonous to humans. Because it decreases the capacity of blood to transport oxygen. The diagram represents the molecule of propane. Describe the forces of attraction between the atoms in a molecule of propane. Strong electrostatic attraction force between bonding pair of electrons. Bonding pairs of electrons. So strong electrostatic attraction. So strong electrostatic attraction force between bonding pair of electrons. So there produces a strong electrostatic attraction force in the bonding pairs of electrons. bromine plus hydrogen bromide. Give the name of this type of reaction. This is a substitution reaction. These are substitute. Total for question 9 equals to 12 marks. This question is about alkanes. A. The graph shows the boiling point of the several unbranched alkane. Number of carbon atoms in molecule and boiling point in vertical axis boiling point. When number of carbon is 5, then boiling point about 37. When number of carbon is 6, then boiling point about 70 degrees Celsius. When number of carbon is 8, the boiling point about 125 degrees Celsius. When a number of carbon atoms in molecule 9, then about 150 degrees Celsius. Draw the curve of base straight line. Use the graph to find the boiling point of the alkane with 7 carbon atoms in the molecule. 7. About 90. 97 degrees Celsius. 97 degrees Celsius. About 97 degrees Celsius. Explain the trend shown by the graph. The boiling point increases as the number of carbon carbons increases. Because
samurai sword on my back. You don't know how to act. Maybe you should relax. Maybe you should relapse. Just kidding. Stop. Woo. Woo. Stop. Stop.
17.2 divided 6.9. So 4. Sorry, the empirical formula CH4. Deduce the molecular formula of the alkene. Sorry. So molecular formula will be H10. The equation for the complete combustion of 1 mole of alkane can be represented by alkane plus Z oxygen ZO2. So X CO2 plus Y H2O. Complete the combustion of 1 mole of alkane produces 308 gram of carbon dioxide and 144 gram of water. X, Y, Z are the number used to balance the equation. Calculate the value X, Y and Z. Mole of carbon dioxide (144) divided by 44. Mole of water so X equal to 7. One hundred 144 water divided by 18, so answer will be 8. So Y equal to 8. Carbon dioxide 308, sorry, it is 308, so 7. And mole of jet, so balancing number so Z equal to 11. So 7, 8, 11. So total for question 10 equals to 14 marks. Last question of this paper. This question is about reaction that form gases. Hydrogen peroxide decomposed to form water and oxygen. The equation for the reaction is 2 hydrogen peroxide, 2 water plus oxygen. 25 centimeter cube of hydrogen peroxide solution are poured into a conical flask and 1 gram of solid manganese oxide is added. Bubbles of oxygen are formed. Give the test for the oxygen gas. Flowing splint collisions, more collision occurs. Per unit time. At the initial surface area of zinc is greatest. The student repeat the experiment at the higher temperature but keeps all the other conditions same. On the grid, draw the curve you would expect the seed in this experiment. So this is the curve will be curved because if the temperature is higher, like this. Like this. So the student repeat the experiment at higher temperature. At higher temperature, the rate of reaction will be more. So curve have above original and starts at 0. Curve goes flat at the same volume. Flat at the same volume. At the same volume. Explain why the rate of reaction is greater if the same mass of zinc powder is used instead of zinc lumps. All other conditions are kept at the same. Because if we use zinc powder, the greater surface area, more collision per unit time, more collisions per unit time, or more frequent collisions. In another experiment, the student adds 0.55 gram of zinc to a solution of containing 2.50 into 10 to the power minus 2 moles of hydrochloric acid. Use the equation to show that the hydrochloric acid is in excess. for 0.83 gram of zinc is needed. Total for question 11 equal to 15 marks. For total for paper 1 110 marks.